So, welcome to all of you skippers out there. Who should we say hi to? Ella. Ella, we miss you. Lauren's crying. She's now leaving. Bye, Lauren. All right. We'll see you later for the day. She can't handle it here without you, so okay. All right. Lauren, don't swear at me. Lauren! Fine. Whatever. Okay. Let's do it. Trigonometric functions of real numbers. Define the following trigonometric functions. We're going to start to do things with these angles. We've talked about angles in degrees and in radians. Now what we're going to do is we are going to insert trigonometric functions. The first one is sine. And so this is literally like when you take the square root of something, you're doing something to that number. And you might say, well, I understand square roots. Really? You understand them really well? So what's the square root of 9? 3. What's the square root of 10? 3 point what? How would you even calculate it? Yeah, all you know is to grab your calculator. You don't actually know how to come up with a square root, do you? Okay, we'll try another one for you. What's the square root of negative 4? 2i. What's the square root of 2i? During this year, I will actually teach you how to calculate the fifth root of 1 minus I roots of 3. That means what times what times what times what times what will end up giving you 1 minus I roots of 3. It seems impossible, doesn't it? Trigonometry will make that possible. But my point is that square root, you know some of the basics, but you don't know how to actually find that. Your calculator does an operation which allows you to find these roots. Well, sine, same thing. Your calculator does something to find the sine of an angle. And here's kind of in your terms of understanding what it does. If we have a terminal point, xy, and we have a radius value, in the unit circle, what is the radius value? In the unit circle, the radius value is 1. So therefore, the sine of theta is said to be, defined to be, y divided by r. And if r is 1, then sine is just the y value. Now it's spelled S-I-N-E. And cosine is C-O-S-I-N-E. Cosine is x over r, or just x. And tangent, T-A-N-G-E-N-T, of theta is y divided by x. What does y divided by x remind you of? Rise or run, slope. Tangent of an angle is the same as the slope of a line. Same thing. So you have these values. Please don't say sin. Like sin. What's the sin, Mr. Gins? Well, adultery and killing and coveting. And, I could go on and on about sin. But it's not sin. It's sign. Say sign. Like, well, and I've had people say, well, I don't know that. You don't know that that means sign? You're not cut out for this class then. I'm sorry. That means sign. So we say cos. Mr. Gins, what's cos? It's not cost. I don't know. What does it cost to be here? Cost? It's not cost. It's not cost. It's cosine. Cosine. Tangent. I understand people say tan. I get tan, but, say tangent, okay? Just say the words. Where do they come from? It's kind of interesting. Like sine, for example. I'll just do one for you. Back when they were, doing trigonometry, if you have an angle, they would stretch a chord from one side to the other of that angle in a circle. And when you divide it in half, you have this angle. You have a 90-degree angle. This is the y value, and they say that sine was, in other words, it was the half chord. And this was many, many years ago, and that word was written in Greek. Well, what happened throughout history is the Greeks were taken over by the Romans. That's when we had the Dark Ages. So, like, mathematics stopped. So when we don't have math, that's when the Dark Ages happened. I'm serious. So, like, if you ever talk about it in history, like, oh, that's when they weren't doing math. That's when the world is bad, right? Yeah, that's basically it. So then, but the Arabics, they were doing things that were actually pretty good with math. They weren't part of that Dark Ages group, and it got translated in Arabic. But then, back in the Renaissance era, when things started come back to light, and they started to have colleges and universities, and people were really smart, they decided to do math again, and they translated it into Latin. Unfortunately, it went from half chord in Greek into Latin or into Arabic as half chord. But the people translating to Latin didn't know Arabic very well. And they didn't really know that word for half chord very well. They thought it meant sinus, the Latin word for your sinuses, your nose, your nasal passage. And so, unfortunately, the term for sine literally means nasal passage. It's supposed to mean half chord, but I wrote a 10-page paper on it. If you want to read it, go ahead. But that's the short of it all. So what do you need to know? You need to know that those are the phrases to say them properly. This means cosecant. It is the reciprocal value of sine, or 1 over y. I should say r over y, which is 1 over y. Secant of theta is r over x, or if r is 1, it's 1 over x. And then cotangent is the reciprocal of tangent. And as you can see in this scenario, you get x over y. Now, some people don't think about x, y, and r. And they say, why don't you just teach me SOHCAHTOA? SOHCAHTOA? Raise your hand if you remember SOHCAHTOA. Okay, well, good for you. I became a teacher with never knowing SOHCAHTOA. Never knew it. You're like, how is that possible? My friend Lisa Dollarshell, she said, Kevin, I was in high school. She said, hey, I heard you're pretty good with math. Will you come help me with math? She went to another school. I said, yeah, I'll help you with math. We sat down and looked at the trigonometry. I said, she was looking at sine. I said, well, that's your y value. She said, what do you mean my y value? I said, well, it's y divided by r. She's like, what are you talking about? I said, well, what did your teacher tell you about sine? She's like, SOHCAHTOA. I said, SOHCA what? And she's like, SOHCAHTOA. And I literally thought that she was confused. I thought she was confusing like a word she had learned in like her American history class. It was like an Indian word that I didn't know. And she was confusing it with mathematics. I literally thought that. I didn't know what SOHCAHTOA meant. She's like, well, it's an acronym, opposite over hypotenuse. I said, why don't you just do X, Y, and R? It's so much easier. And the tutoring session did not go well. So I memorized this. And still in my work, I just always write down X, Y, and R. I don't do opposite over hypotenuse and that stuff. I'll teach you how to do it still because I have to teach you. And, we do right triangles. But I always do X, Y, and R all the time, 100% of the time. So let's do it. Draw a picture. Use special triangles to calculate the exact value of the following trigonometric functions. We want to do sine of pi over 3. There's an exact value there. So what do? I convert pi over 3 to degrees. What is it? 60. That's why I had you quiz on it. I don't want to go over it. 60 degrees. Sweet. What kind of triangle do I have? 30, 60, 90. What's the radius? 1. If that's 1, what's the bottom part? 1/2. What's the side? Root of 3 over 2. So what is the xy coordinate? 1/2 root of 3 over 2. So sine of pi over 3 is going to be the y value, which is root of 3 over 2. That's the exact value. You were able to calculate it without the use of your calculator. Take out your, what's like, calcu now, calculator. All right, okay. All right, so turn it on. If you like watch videos back, I have so many jokes you guys don't pick up on. All right, I'm going to mode. Mode, that's where we need to be. Your calculator has different modes. You need to understand this class when you're working in degrees and when you're working in radians. Right now, for this problem, should I be in degrees or radians? Radians. Now, you might ask yourself, well, Mr. Gens, I don't know when to go to degrees or radians. If it's in radians, you go to radians. Now, some people misunderstand, and they're like, they're not even do sine or cosine tangent. They're like, should I be in degrees or radians? It doesn't matter. 4 times 5 will give you 20, whether you're in degrees or radians. But if you press sine, cosine, or tangent, you got to be careful with these two. So I'm going to go ahead and focus on radians right now. I'm going to quit. I'm going to take the sine, second pi, divided by 3, and I get 0.866. Now, if you take the root of 3, parenthesis, and divide it by 2, I get the same exact thing. Now, for those of you who will go to this test and not know what you're doing, here's what you'll do for this problem. You'll see the sine of pi over 3, and you'll write this. You'll write 0.866, because you'll just type into your calculator. And I give you exactly 0 points for that, because I say, find me the exact value. The exact value is square root of 3 over 2. That's approximate. This is exact. You have to be able to do this, not just punch in your calculator. Am I clear? Okay. So Some people during the last hour said, well, what if we were in degrees? Well, if I change it to degrees, notice what happens. If I quit and instead of sine of pi over 3, if I do sine of 60, sure enough, I get 0.866. But if you did sine of pi over 3 and you're working in degrees, pi divided by 3, think about it. Pi is about 3, right? If you divide that by 3, you get a value close to 1. So this is going to find the sine of about 1 degree right now, which is very close to 0. And sure enough, I get 0.01. So please make sure you're working in the right format. Let's move down here to letter C. We are not just going to do the tangent of 7 pi over 4. We're going to find all of them. We're going to do the sine of 7 pi over 4, cosine of 7 pi over 4, tangent of 7 pi over 4, cosecant of 7 pi over 4, secant of 7 pi over 4, and the cotangent of 7 pi over 4. I know that this is what you were hoping to do on your Friday, and I'm not going to let you down. I'm not going to rob you of any learning. Draw my fancy-dancy circle, 7 pi over 4, convert it to degrees, go. What do you got? 315. Nice job. Giacchi passed his test. 315 degrees. So what kind of triangle do I have? 45, 45, 90. What's the length of the radius? 1. What's the other side? Yeah, 1 divided by the root of 2, which is the root of 2 over 2, correct? So this is root of 2 over 2 as well. So what is the coordinate? Somebody tell me. Very good. So we got root of 2 over 2 and negative root of 2 over 2. If you didn't do your terminal points worksheet, that won't look as familiar. But we had that as an assignment, right? So you had to be able to do that in order to do what we're going to do today. So what sign then? Negative root of 2 over 2. So if you know how to do this, then today's not that bad. But if you don't know how to do this, then yeah, it's pretty tough. Cosine, 2 over 2. Tangent, negative 1. They're the same values, just one is opposite. So you're going to get negative 1 if you divide them. You all good with that? Before you try cosecant, I would have to take the reciprocal of sine, right? Can I show you the long way of doing it and the short way of doing it? Here's the long way. The long way is negative 2 over the root of 2. And you say, uh-oh, I have to simplify it. I can't have a root of 2 in the denominator. So you get negative 2 roots of 2 over 2. And you cancel it out and you get negative root of 2. Okay, fine. Well, there's an easier way to do it. Look at where the root of 2 over 2 came from. It came from 1 over the root of 2. If you take the reciprocal of 1 over the root of 2, you get root of 2. So you can look at where it came from. We'll look at that again as well. Okay. So what's secant going to be? Just root of 2. Yep. Cotangent. What's the reciprocal of negative 1? Is it 1 or negative 1? I have 1 over negative 1, and I take the reciprocal. Does it change value? No. Okay, let's move up, try another one, then we'll get you an assignment. It is a worksheet. Let's do theta equals negative 7 pi over 6. Oh, no, Mr. Gantz, you gave us a negative. Well, what is 7 pi over 6 in degrees? Yep. Negative 210. Very good. So if I do negative 210, negative 210, that's the same as 150 degrees, right? So 210 is the same as, negative 210 is the same as 150. They are coterminal. That's something we've talked about before, right? So however you want to think of it is fine. So I have, very good, at 30 to 60, 90. Length of my radius is 1. So what do I have now? Yep. So what's my terminal point? Negative root of 3 over 2, 1/2. So if I want to list all 6 of these, let me do the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, secant of theta, and cotangent of theta. What is sine? 1/2, piece of cake, upside down. Cosine. Negative root of 3 over 2. How do I find tangent? Yeah, y divided by x. So no easy way around this. 1 over 2 divided by negative root of 3 over 2. How do I do that? Multiply by the reciprocal. So times negative 2 over the root of 3. What happens to the 2's? So I get negative 1 over the root of 3. Can I have that? Multiply top and bottom by the root of 3. I get negative root of 3 over 3. Cosecant. Yeah, the reciprocal 1/2 is 2. Reciprocal secant would be negative 2 over the root of 3. Can't leave that root of 3. Negative 2 roots of 3 over 3. Cotangent. Pause. Don't flip this one. Flip where it came from. See that? If you just think about your work, you'll save yourself some time. Don't flip this one. Flip the one before it. I get negative root of 3. No yawning. This is exciting. Huh? Not too bad, huh? No, that was calculus. We added up the area of an infinite number of rectangles. Seems impossible. It's not impossible. All right, I'm going to hand you your work.